This video is a breakdown of two major vulnerabilities in WordPress that lead to RCE. And to kind of set the stage, I want to show you how serious the situation is. On my machine here, I have a default install of WordPress version 7.0.0 running on my machine. And I'm going to run the exploit right now and show you that it's very quick and it works every time. So what we're going to do is first run a check on the site. What it does is it scans the site on the right to see if the vulnerable path, the REST batch path, is active and returns the proper error code 207, which means it is vulnerable. And then if I go to shell on this device, we're going to go ahead and do shell with an interactive shell, and then it uploads a web shell, and now I have a shell on the device. Obviously running as a unprivileged user, but that's a different conversation for later in the video. I want to talk about this bug, why it works the way that it works, why it's so beautiful, and how it was found in the first place. And also what you can do if you're a defender worried about bugs like this in the future. Now, I want to be very clear, there are only a certain number of versions of WordPress that are vulnerable to this, and it's actually kind of ironic that if you are running a version before 6.8.5, you're not vulnerable to this, right? It's another one of those scenarios where you actually don't get new vulnerable features by not updating, which is kind of weird. So if you're outside of the range of any of these, you are not affected. And if you update right now to 7.0.2, you are also not affected. I want to highlight that WordPress, while it may be a very simple web framework, a lot of you guys maybe like React or Angular Andes who watch my videos, but it's important to highlight that I think I read somewhere that 42% of all blogs on the internet, and that includes blogs, restaurants that have front pages, like the Thai restaurant down the street from my house that I eat at on a weekly basis, that is all done on WordPress. A lot of people use WordPress. And the scary part is a lot of bugs in the past that have been found in WordPress have been bugs in a random WordPress plugin, maybe some custom food they downloaded off of a scary plugin site. This is just the default feature. Now, the actual vulnerability stems from this batch v1 endpoint, okay? It is an unauthenticated endpoint that allows you to run sub requests in a single call. Now, when I read that, I was like, why did that even exist in the first place? That's a very weird endpoint. Now, the design of this endpoint, the batch v1, actually makes a lot of sense. So if you consider what WordPress is literally a blog. You make pages and you use them in some kind of local editor. And every time you make a change in the editor, ideally what you want to do is have that edit be reflected in WordPress. Well, the problem is that if every one of those edits creates a request, you get kind of a very noisy back and forth where every single change is like a post request to the site. To reduce the amount of noise, in October of 2020, the authors of WordPress introduced this batch v1 method that allows you to batch together multiple REST API requests up to 25 to WordPress. Actually a great idea, and even better, the API calls, they still go through proper authentication, meaning that you can't just use the batch request to batch a request to create an admin user, right? So the authentication is still there, but there was one bug in the REST API handler that was recently found, the CVE number 1 for this chain. Now, it's important to highlight that this handler is not supporting GET requests, right? It is literally just meant to batch changes to WordPress pages. So the batch handler only supports post requests, which is important for the next bug. So I'll read this out of the write-up here. So basically, the serve batch request v1, which we'll look at here in a second, builds two parallel arrays, matches and validation, and then indexes both of them off the same offset when dispatching the request. A sub request path whose path fails WP parse URL is appended to validation, but not to matches. We have kind of an out of order, an index mismatch. So the arrays fall out of step, they're no longer aligned, and a sub request is dispatched under a different sub request handler. That is a route confusion. And you'll see the actual patch that fixes that is when you have an error on the way that the path is parsed, it appends the request to both matches and to validation. This single line was not in this request handler previous to this, and because of that, you were able to use the REST API batch handler to batch request a GET request. And you may be wondering, what is so bad about a GET request? Well, this is where the next bug comes in. Bug number 2, the second bug in this exploit, again, it's 2026 and these kinds of bugs are still happening. There was an SQL injection in the WordPress post query method where if you're able to use the author not in values, if you're able to use the field author not in, if you're able to specify the content of that, up until now, it was not specified that author not in had to be an integer, author not in being the post ID number. What you could do is SQL inject the author not in field. Now, up until this point, this field was actually validated using another field called author excludes. So author excludes mapped to author not in, but before it got to author not in, it was sanitized. Aha! But what you're able to do using this exploit is use the route mismatch issue to dispatch the request to some random post that doesn't exist, and you're able to use the author exclude, order by, and per page parameters in that query param to write data to the author not in field, which then triggers the SQL injection. That's insane. That is absolutely crazy. So because we're able to dispatch your request inside of a WordPress on the inside of it, it doesn't go through the proper sanitization that author exclude normally goes to. And because of that, the author not in field gets hit. SQL injection. Now, the next part of the exploit took me so long to understand that I think I finally get it, but this is where truly gets beautiful. I'm doing this. My son is now old enough to say more. So I do this like subconsciously. More? You want more exploits? Okay. For anybody that has done web app pen testing, this is a blind SQLi. Okay. For those of you that have not, a blind SQL injection is an SQL injection that occurs where you do not see the result, right? So for example, we were using this on a login, it would not be blind to inject this field because you would be able to get into the login, right? The result of the operation would be visible to you. When you have an SQL injection that occurs internal to the database and there's no result posted to you, it is very difficult, actually it's impossible, to see the result directly from the injection itself. So what you have to do is use some kind of side channel to create either a binary yes or no about the result of the SQL injection to reveal some kind of data about the contents of the query. Let me show you an example. So when you're doing an SQL injection attack where you have a blind SQLi, what you can do these things called conditional time delays, right? This is like the kind of the go-to like CTF version of a blind SQLi. So basically what happens is you have your yes case and your no case, right? So select if some condition, sleep, otherwise something else, right? And your condition can be like user.password is like capital A, right? It starts with the letter A. And if it's correct, if it does start with the letter A, you will have a 10-second sleep, right? And if it does not, it will return some garbage very quickly. What you can do is use that side channel, the amount of time it takes to run this, to reveal contents of the user, right? So you can use this to kind of leak out data around the database. The problem is this takes a very long time. You have 255 possibilities times 10 seconds per failure times the number of characters that a SHA-256 hash can be, right? This can take a very long time to do. And even then, you're only revealing the hash of the password. You're not actually getting anything important. What happens here is they somehow figured out how to use an SQL select injection, which is by default not allowed to do database insertions, to do a object cache poisoning, an object hydration cache poisoning that creates a fake post, and that fake post uploads a web shell. Let me show you. So ultimately, and again, I'm not sure that I fully understand the full end-to-end here, but as far as I understand it, it makes a request out to a post that doesn't exist. By creating that post request, it actually internal to WordPress makes a embed cache post. So it's a temporary post that doesn't actually exist for purposes of caching. And then it's going to reveal the cache post ID using the SQLi. And then from there, it's going to poison the batch request by making a customize or change set, which is a way that you can internally at WordPress like change posts, and then make that post do another post to the endpoint WordPress v2 users. But because all of this is running in the context of an admin internally, you're able to use that to create a new user that is an admin, and then they use that admin to log in and upload a regular plugin. And that plugin, oh, by the way, is a web shell. And I'll show you the web shell here if I just cat it real quick. Very simple web shell, right? So it has basically, if the string on the front of the web shell equals some secret password, right, which is just some hash, get the value and then run the value as a shell command in shell exec. Or literally, so that's what we're doing right now. I can do ls, I can do id, whatever. What makes it even worse, guys, is like if you get hacked by this, there is also like a recent string of Linux kernel LPEs, local privilege escalations, that allow you to kind of just become root for virtually free. In fact, the last, like a lot of versions of Linux, almost all the distros, I've made several videos about those. I'm not going to go too deep in those. Go watch those videos. Here, cards above. One important piece to highlight, and I know you guys are super sick of me talking about this, but it's the nature of the game right now. It is the world we live in. It's important to highlight that AI was definitely involved in the creation of this POC, right? So if you consider like these two bugs separately, like an SQL injection that's not accessible from the front end, and the ability to dispatch a request that shouldn't be a GET request in a route dispatcher, those two separate things are like not that bad individually, right? But the ability to take these two disclosures, which came out, I believe, on July 16th. And then in 10 hours, a proof of concept came out that not only exploits it, but exploits it almost instantaneously. Again, don't forget, this is a blind SQL injection. A blind SQLi is historically one of those things that requires very important timing. You have to be able to measure how much time the request takes. And if you want to make it really, really accurate, you have to increase those sleeps. So doing it like this, where you're able to poison the internal object cache, again, a method that I truly still don't get completely, is one of those things that, like Tenable says, only AI could have solved this problem in 10 hours. And again, I'm not saying people aren't smart. People are very, very smart. This is just a very nuanced, interesting way to solve this problem. And again, it works without error. Now, as I mentioned before, there are a bunch of Linux privesks that are out publicly right now that if you're on a box and like you think you may have been popped by this, there is a very high chance the threat actor may also have root on your box. In my personal opinion, what I would do in that scenario is just literally take your code, destroy the box, get a new one, and put the code back on it, patch, and do all that stuff. Again, if you are at version 7.02 or higher, you're not vulnerable to this. And so patch your boxes. If you want to learn more about those LPEs, how they're exploited, and why they are as cool as they are, check out the video that I link here, and we'll see you in the next one. No, Rust would not have fixed this. I love you. Goodbye.